square trinomial? A perfect square trinomial is the result of squaring a binomial. It has first and last terms, which are perfect squares, and a middle term, which is twice the product of the square root of the first and last terms. So how do we easily identify a perfect square trinomial? So the perfect square trinomial comes in two forms. So we have a squared plus 2ab plus b squared and a squared minus 2ab plus b squared. So the first term, which is a squared, is a perfect square. And the last term, which is b squared, is also a perfect square. So the first and last terms are perfect squares and they are always positive. And the middle term is always twice the product of the first and last terms. How do we factor perfect square trinomials? Step number 1, examine whether the first term and last term are perfect squares. Step number 2, look at the middle term. Check whether it is twice the product of the square root of the first term and last term. Step number 3, if conditions 1 and 2 are satisfied, then the expression is a perfect square trinomial. And step number 4, factor completely the given trinomial following the pattern number 1. If you have a squared plus 2ab plus b squared, then you can factor it as the quantity a plus b squared or a plus b times a plus b. So if the middle term of the perfect square trinomial is positive, then the sign in between the binomial is also positive. And if you have the trinomial a squared minus 2ab plus b squared, then you can factor it as the quantity a minus b squared or a minus b times a minus b. So if the middle term of the perfect square trinomial is negative, then the sign in between the binomial is also negative. Let's try example number 1. So we're going to get the factors of n squared plus 16n plus 64. So what are we going to do? Check whether the first and last terms are perfect squares. So the first term is n squared and it can be written as n times n, and 64 can be written as 8 squared or 8 times 8. And checking for the middle term, so we have n times 8 is 8n times 2 is 16n. So we have a perfect square trinomial. And writing the factors following the pattern, so the first term is n and the last term is 8. So we have the quantity n plus 8 squared or n plus 8 times n plus 8, which is the square of binomial. Example number 2. So we're going to get the factors of 4x squared plus 4x plus 1. Again, check whether the first and last terms are perfect squares and write them as a square. So 4x squared can be written as 2x quantity squared or 2x times 2x. And 1 can be written as 1 times 1. And checking for the middle term, so we have 2x times 1 is 2x times 2 is 4x. So we have a perfect square trinomial. So writing the factors following the pattern, so we have the first term which is 2x and the last term which is 1. So we have the quantity 2x plus 1 squared or 2x plus 1 times 2x plus 1, which is the square of binomial. Example number 3. We're going to get the factors of x squared plus 14xy plus 49y squared. Again, check whether the first and last terms are perfect squares and write them as a square. So x squared can be written as x times x and 49y squared can be written as 7y quantity squared or 7y times 7y. And checking for the middle term, so we have x times 7y is 7xy times 2 is 14xy. So we have a perfect square trinomial. And writing the factors following the pattern, so the first term is x and the last term is 7y. So we have the quantity x plus 7y squared or x plus 7y times x plus 7y, which is the square of binomial.